Okay, today's task is n queens. I guess quite popular among somebody. Task. I guess I saw that many times actually. Maybe like throughout last 2 years, or like 3 years even. I saw that like a dozen times. Um, so I'll try to solve it again. Actually, I don't remember the solution. Let me quickly read the problem. I'll try to sketch it, and then yep. So the idea is to use right now is if I put the queen on a row, I should put a queen on the row. Let's say start the queen on the first row, and that means that I cannot use the first column, like if I put it on there. So like every queen should stay on separate rows. The first idea is because if they're gonna stay on the same row, they can kill each other. So the queen goes like on the like vertical, horizontal, vertical, and diagonal trajectories. So first I'll start with putting the queen on this cell, let's say on the top row, zero cell, zero column. Then it means I'm gonna move to the next row, and I basically need to check only those columns that are not used first, and second I should to avoid like this situation, and second I should check that the diagonals are not uh, like I are not occupied there. So for this, like if I put the queen, let's say you have 4 by 4, 4 by 4 grid. Let's say we have 4 by 4. Um, so if I put queen here, it means this is busy, this was busy, and also this is busy. And then I can put generally like 2 queens on the next row. I can put here, or I can make this a little bit smaller and draw this another one. 3, 4, 1, 2, 3. So I put the queen here, and let's say I use the diagonals, like vertical, horizontal, and diagonal. And let's say I put the queen here. It means that this column becomes busy and this diagonal becomes busy. So I generally need two diagonals and counter diagonals. Like diagonal is gonna be like this cells, and counter diagonal is gonna be like this cell, this cell. So they go from top right to the bottom left. It's counter diagonal, counter D, and the diagonal goes from top left to the bottom right, like this. This is diagonal. So here I used this. So this one is busy. So I can put maximum. Oh, okay, and this one also busy. So this one is not working because if I put it there, this diagonals, there is no options to put the queen on the third row, like here, because wherever I put it, it will be killed. Yeah, and it means that this is not valid, like board. And in this situation, I can generally put it here, and again, I won't be able to put the queen on the last row. So this one is also not valid. So it means that I need to consider a next cell for the first row. So like I was considering like this cell, it was not working. So I'll consider this one, and I'll again, oh, I missed one. I'll again do the backtracking. Then I can put only one option available here, and again I'll do this one, and also here only one option available. And then I finally can put the last one here. So like this one was okay. Let's consider third cell, like you start from 0, second cell, like so I put the queen here, and I marked all the rows that now that are now used, and all the diagonals, and like counter diagonals and null diagonals, and that leaves me with one option like this. Put the queen here, and again I marked it like as used, and then leaves with one option here, and again I marked this one as used, and this basically leaves me with interesting with two options. Actually I can put the no, actually with one option, because this one is also busy. So it leaves me with one option like this, and this one is for this queen, if queen starts at the cell, if I start putting queens at the cell. So next I'll put the queen on the last cell for first row. If I put the queen there, I'll do the following. So I'll put the queen there, I'll mark it like this, like this, like this, like this, like this, like this. Now I have like two options. The first option will be to put queen like here on the second row, and the second option will be to put it like a little bit further, like this, like this. So I put it here, also mark it like here, 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 here. And now I put it on a second column, and this will generate these options, these options, uh, these options, these options. So now I cannot put anything on a third row because all of them are busy in this case. So I stop iterating, and in this case I can put something on the third row like this. But when I'm gonna proceed to the last row, I won't be able to find a place to put the queen, so this one option is also not available. So out of like all possible passes, I had like only two combinations that were valid. I mean, like I placed 4 queens on 4x4 board, and they are not able to kill each other in this like allocation. So the answer should have like just two. The question is now how I can efficiently program the diagonals and like vertical and horizontal rows checks. So for the horizontal and vertical rows, I can just have a hash set and fill it with 0, 1s, whatever. Now like I can have like hash set or even array int, and this one will be rows, and then gonna be integer there, and then columns, also integer. And then I can also put the diagonals. Yeah, like I can have d for the diagonals, and there will be 1, 2, 3, 4, 5, 6, 7 diagonals, and let's mark this diagonal that starts at this one 0. There's going to be 1, 2, 3. This one that starts here -1, like this diagonal. Going to be -2, -3. And contour diagonals also going to be so like let's draw this one. Maybe it's going to be more clear. So this one gonna be diagonal number 0. The next one gonna be diagonal 1, and so on, so on. This one diagonal gonna be -1, and this diagonal gonna be like 2, and the last one gonna be 3, and here I'm gonna proceed. This one gonna be -2, and this one gonna be -3. And the same I'm gonna proceed with counter diagonals. So for the main diagonal, let's call this diagonal 3. This is gonna be diagonal 2. This one gonna be okay. The only question that's left right now is like if so I will color and let me finish the coloring. So this counter diagonal gonna be 0, and then let's call this one. This one gonna be 4. This one gonna be 5, be a 5 like this, and this one gonna be 6. So the question is, given the cell, how we can find the row, column, and diagonal and counter diagonal to remove from the hash set? So let's assume I'm currently staying on this cell, on this cell. So the cell is a row 2, column, cell row 2, column 3. So the row to delete gonna be 2, column to delete gonna be 3, the diagonal to delete gonna be, so the diagonals like should be 1. So it should depend on the row and the column. So this line should go like x. So the main diagonal is just x equal y. Like if I use column as a x, it's gonna be x axis, and this one. So the y-axis is gonna be 0, 1, 2, 3. So this the main diagonal is y, so the row equals x. The next diagonal gonna be y equal x minus minus 1. The third one gonna be x minus 2, and the fourth one gonna be x minus 3. So to find out which diagonal we should use, I should basically uh, convert this cell to this cell. And how to do that? I need to, so I have like x equals 3 and y equals 2. So if I subtract x equal like 3 minus 2, then y equals 2 minus 2. So y is equal 0, here is equal 1. So I should subtract just for this cell, I should to figure out the diagonal, I should just subtract column number minus row number. So for this one, column number minus row number gonna be 2 minus 1 gonna be 1. This one all the same. Column number minus row number gonna be 1. For this one, it's gonna be 0. For this cell, column number 0 minus row number 1 gonna be minus 1. That applies. So to figure out the diagonal number, diagonal gonna be equals row equals column, and diagonal number of diagonal equals column minus row. And the counter diagonal, let's say for this cell, I need to figure out what the counter diagonal for that one is CD. Let's say CD. And the counter diagonal for that one, so the equation for this one, so it's gonna be y equals something minus x, and then for this diagonal is gonna be So it's should be what? Should be 5, 4, 5. So it should be minus x uh, plus 5. Yes, minus x plus 5. And this one gonna be uh, this. So this one gonna be to figure out the counter diagonal number. So let's check if I have minus x plus 5. So let's say I want to have minus 3 or minus 2 plus 5. And it's gonna be what? 3, not, yeah, it's gonna be 3. If I gonna put minus, okay, minus 3 plus 5, it's gonna be 2 equals 2. Okay, that's true. That's working for these two cells. So in order to find the counter diagonal for this one, I need to figure out what's the how to write this one. So the angle is like 45 degrees, like minus whatever, like minus 45 degrees. Or like no, like here it was 45 degrees, and here is like whatever it is, like angle y over x equals minus 1, something like that. So it should be something like uh, y. So if rho equals 3 and oh, if row equals 2 and column equals 1, the row equals 2 and column equals 1. No, column equals 3. So for this one to be 5, I need to basically add one to the another. Yes. So here we have a row equals 4, 3, and columns equals 2. So to find the counter diagonal, I need to just do this. This was column minus row, and this one gonna be a row plus column. That's gonna be the counter diagonal, and counter diagonal number is gonna be from 0 to 0 to n and up to n and 2n minus 2. So the counter diagonal is gonna be from 0 to 2n minus 2, and then diagonal is gonna be from minus n plus 1, 0 to n plus 1. This one, yep. So let me program this one. Um, So there, I'm gonna have this, let's say hash set uh, integer rows equals new hash set, and then hash set integer columns calls equals new hash set, and then for int I equals 0, I less than n, I plus plus, and then I'm gonna add rows, add I calls, add I, and then I'll have diagonals, integer diagonals, dia diagonals equals new hash set, and then I'll have hash set integer cd diagonals, new hash set, and then I'll go and do this following. I will, for the diagonals, I need to fill up the diagonals. So the diagonal is gonna be filling up hash set hash diagonals, add I, and then diagonals, add minus I, and then C diagonals, gonna add I multiplied by 2, and then C diagonals, add I multiplied by 2 plus 1. Seems like this. And then I'll go BT, like list string BT. It will accept the int row, and it will accept the positions of the queen. Let's say I will have the int um, positions, and I'll have rows. All these sets of the hash set integer rows, and then so on and so forth. Calls hash set diagonals and hash set C diagonals. I'll have also the result. Let's have result list of the string result, or like let's say output. And then for the if row equals, let's say I'll have also n int n. If row equals n, it means that I'll need to add the have this void add result. It will add position, have accept the position, and I'll accept the output array. And then for this one function, I'll do this string builder as b equals new string builder, Okay, list string equals new list, and then for int I equals 0, I'll add in positions dot length I plus plus. I will do for int j equals 0, j less than n, j position queen equals position dot I, and then y j is less than position 0, j plus plus. I need to add sb add dot, and then sb add q, and then for in j equal plus 1 plus 1, j less than n, j plus plus. I need to sb dot add, and then another dot, and then I'll need to add output, or like board add sb to string, and then I'll go to output dot add board, and then that's gonna be it. And if n is row is equal n, I'll go add result plus dot output, and I need to return from here, otherwise I'll go for in j actually I don't know, I don't need rows here because I'll go iteratively row by row. For let's say integer, so I need to go for the key set hash integer key. So the problem here is that I can modify the hash set while I'll be iterating. So for that, let's check calls key set, and then call, and then I'll go for let's say diagonal for the current call in the current row. The int diagonal gonna be call minus row, and then int C diagonal gonna be col plus row. So we need to check if cols contains diagonal. Oh no, if diagonals contains diagonal, and C diagonals contains C diagonal, I'll need to go and remove it. So diagonal remove diag, and then C diagonals remove C diagonal, and then I'll add the pause row equals 0 equals row, and pause row 1 equals call. And then I need to call bt row plus 1 pause and calls diagonals, content diagonals, and output. And then I need to add it back, diags, and diag, and C diags. And also I need to to remove calls. Yeah, calls remove. Okay, so it already contains it. Calls remove call, and then calls add call. Yeah, something like that. But probably this one will not work. So this is part 2 of this solution of the problem. So I was interrupted on the while I was doing this type of solution, and the problem with this solution is that if I solve the sketches, initially I add all columns to the hash set, I add all the diagonals to the hash set, I add all the counter diagonals to the hash set here, and like diagonals from minus n plus 1 to 0 to n minus 1, and the counter diagonals are from 0 to n plus 1. Yeah. So if I add all of them, then I go bt backtracking. Say here, this is this. I go backtracking. If the row is equal to n, I add the result. It means we put all the queens on the board. Board is full, is like queens with their positions are stored here in pos two-dimensional matrix. So I go for the every row, I go through the columns that are left, and it means that if I put the rook there, the queen there, it will not be killed. And then I calculate the diagonal and counter diagonal for this row and cell, and check if I can put this queen there. So if the call is available, and if the row is available, if the call is available, row is already available because I go row by row. If the diagonal is available and if the counter diagonal is available, if it's not like occupied. So I occupy the column diagonal counter diagonal. I add the queen to the current row and column, and iterate BT with next row and the same kind of hash sets. And then I'll add the column diagonal counter diagonal after iterating back to the hash sets so that I can reuse it into the next board try. And the function add result, it will just form out of the position of the queens and the output list of lists of strings. Where should I put the output and that size of the board? It will form the board itself and will add it to the output. So this one was promising, even though but the problem is that calls, so I modify calls while iterating over it, and while it's kind of showstopper here, and what I want to do here is just to switch from the hash sets to boolean arrays, and do this boolean calls equals new boolean. So we have an n number of columns. Add whenever value is false, I mean it's available for usage. Whenever it's value for the columns or like diagonal counter diagonals true, it means it's occupied. So I will create boolean also diagonals. So new number of diagonals gonna be n minus 1 plus n minus 1 plus 1. So it's gonna be 2n minus 1. And the same number of counter diagonals. Gonna be new boolean the same 2n minus 1. So I'll remove all of this and I'll change the parameters here. Gonna be boolean, boolean, and boolean. So next I have this interesting rows here, diagonals here actually. So here diagonal is from minus n plus 1 to 0 to n plus 1, and I need to convert it to range from 0 to n minus 1. And here the counter diagonals are from in the range of 0 to n minus 1. So I am fine with that. So the only change that I need to make is write down diagonal equals uh, diagonal plus n minus 1. So all the values shift to the right. And now I'm gonna have put for the integer in L, let's say in call equals 0, call less than n, call plus plus, and then I'll need to check if not true calls call and not true diags diag and not true c diagonals c diag. If they are not occupied, then I'll do the following. I'll make them occupied, something like this. Go through. I'll remove this, and then I'll put them after iterating backtracking. I'll make them false. False. And then I'll initialize them, initialize the output. I'll call the pt for the output, and I return the output. Something like this. Yeah, that's it. This is very hacky. Okay, whatever. Hope you like my explanation. My tutorial is closed. Yeah, that's it. It was the nquint problem. So to walk you through the solution, what I do here, how to show it. Mm. Okay, to give a short summary of the solution. First, I fill the calls diagonals, counter diagonals arrays with by default I initialize them, they are false. It means that they are available. So diagonals, counter diagonals, and columns. And I start BT. Backtracking checks step of the backtracking is a row. So I call backtracking for each new next row. And for the row, I check if I wanna put Now a queen on a selected column, and I check every column that's available. So for every column, I have column and row coordinates of the cell, so I can calculate the diagonal and counter-diagonal ID. ID here I've chosen as intersection of diagonal with the x-axis. Um, but because um, uh, diagonal is in the range -n+1 to n+1, and I have just a boolean array, I convert this diagonal, I add just -n+1 to all numbers generated, and it will convert this range to this range, to the range from 0 to n-1. So I check if the column and diagonal and counter-diagonal are not busy, not occupied. Then I specifically may occupy it, add the queen to the row and call, and then go inside the recursion, like do the BT iteration for the next row. And when I exit this BT, if that was successful, the successful board is saved into the output. I need just restore the state. So the next time we're gonna go to BT, it will not affect that iteration. That's gonna be completely separate. And for the result, if I manage to go until the end, until the final row, and process the final row and pointer pointing to the end, I'll add the result to the output, and the result is saved like the all positions of the queen for the current like BT pass is stored in the pos array, and I'll create a board of list of strings. I'll go through the positions, and for the every kind of, I know that they are ordered by rows because I was going there by row, BT, and only call BT start from 0 row and only call BT for the next row. So they are all ordered by rows. So the queen at position 0 is located in the row number 0, queen at position of number 1 is located at the row number 1, and so on and so forth. So I fill up the first row until the queen with dots, and then add the queen, and then fill up the remainder of the row with dots, and then add and the current row to the board, and then proceed to the next row, and so on and so forth until I build up the board, and I'll add the board to the output and return from this function. Yeah, so that's it. Hope you enjoyed it. As I said, no, I didn't say that. So it took me more than like 20 minutes to solve this task. It's well over, like if I count like two parts, it's like well over like maybe 45 minutes, 50 minutes. So I consider that fail. Yeah, that's it.